Maybe something. I have a microphone, but I hate using it. Thank you, Andrew, and I'll have a special thank you at the end. But today what I wanted to do was actually run through a variety of ideas very quickly. I wanted to make this kind of open, so hopefully we have some time for questions at the end. And I'm going to address a couple of topics, although I've got one that's optional at the end. So this talk is, what does evolution tell us about religion? Obviously, we're all here because we recognize there's some kind of fuss about science and religion, and at least the perception of a conflict between the two. And to resolve that, at least to my satisfaction, I'm sure not to everyone's satisfaction, we're going to have to talk a little bit about what science is, how does it work, and then we'll ask the question whether or not evolution qualifies as science, because, well, obviously I intend to connect the two. And I'll be quite frank, I hope I get to this point where I get to make fun of intelligent design, because it is a subject for which one should show no mercy. I'm quite empathetic to a variety of viewpoints, but that's not one of them. So I want to start off with 4 quotes. The first of those is by Richard Dawkins. The universe we observe is precisely the properties we should expect if there is at bottom no design, no purpose, no evil, no good. I didn't say no nothing. Nothing but blind, pitiless indifference. Another quote, and I like this one especially because another quote also by Dawkins is that an atheist before Darwin could have said, I have no explanation for complex biological design. All I know is that God isn't a good explanation, so I must wait and hope for something better. But he goes on to say, I can't help but feeling that such a position, though logically sound, would have been unsatisfying. And although atheism is logically tenable before Darwin, Darwin made it possible to be an intellectually fulfilled atheist. Therefore, Darwin really must have done something pretty clever if he now made it, so atheism was kind of an okay idea, but now it's a perfectly reasonable notion that you should be quite satisfied and fulfilled embracing. Now, I want to contrast that to what's commonly said the other side of this issue, but this is from Henry Morris, the founder of the Institute for Creation Research. If you want to know anything about creation, its time, its duration, the order, methods, anything else, the sole source of that is divine revelation, and you're completely limited to what God has seen fit to tell us. I find that an interesting phrasing because it means God didn't see fit to tell us some things. And this information is in His written word. This is our textbook on the science of creation. This is from Answers in Genesis, and I reordered this if you go look it up. But the account of origins presented in Genesis is a simple but factual presentation of actual events. Therefore, it provides a reliable framework for scientific research into the question of the origin and history of life, mankind, the earth, and the universe. So if that wasn't enough, no apparent perceived or claimed evidence of any field, including history, chronology, I assume art, music, you name it, can be valid if it contradicts the scriptural record. So, this talk could be very, very short, because I want to point out that those two, and actually I don't like to say sides, those two sets of extremists, because I think there's a giant group in the middle, all agree. I know those statements didn't sound like they agree, but they do agree that science and evolution have something to tell us about religion that they reject it. So science rejects religion. Now they disagree about sort of what you should do next. So one side, Dawkins and others, maintain, okay, we're done now. Since science has rejected religion, there is no God, and we don't have anything else to talk about. The creationists argue that since we know there is a God, and science rejects religion, that the science has to be wrong. So pure and simple, that these two sets of conclusions. Now, the whole point of this talk is going to be this: they have something else in common. They're both wrong. That is to say, and the major thesis here is science has nothing to say about religion, and it can't. So to do that, we're going to use a very simple example. I use this one in class all the time. I see 1 or 2 students out there, so they're going to be, oh my. This is I've heard this before. So the first thing we need to do is ask ourselves, what is science? And science is much in debate by historians and philosophers and other people who debate those things. Interestingly enough, scientists don't spend any time very much trying to figure out what science is. They just go out and do it. And in fact, that's wise, because science is distinguished by its methodology, how it pursues questions. And so we're going to look at a question involving this fish, which is a sockeye salmon, and briefly go over some experiments and observations on this fish to illustrate how the scientific inquiry works. So, it starts with a set of observations, actually. I've simplified this to some degree. Salmon observations, mark tagging, recapture experiments demonstrate that salmon are born in a freshwater stream as little bitty fish, about the size of your little finger. They migrate out to the sea. They spend 4, 5, 6 years, depending on species out there. Some of them travel thousands of miles, and then when it's time to spawn, to reproduce, they return back to the very stream that they reproduced in, which is, that's quite a feat. So obviously, that attracted people's attention. So the next question was, science forms a hypothesis to explain that observation, a tentative explanation, if you will. And in this case, the hypothesis is that salmon use visual cues to find their way back to spawn. Visual cues like features of the streams, turn left at the big log, celestial navigation, go towards that big bright star. And most of you, of course, know how salmon find their way home, so you might think this is silly, but notice it's not silly, because after all, this is how everybody I see in the room intends to find their way home. You plan on using visual cues to find your way back home, and so what predictions does the hypothesis make? Because science works by examining the predictions the hypothesis makes and then testing the prediction. So one such prediction is that if we blinded the fish, they wouldn't be able to find their way back to their natal stream. So I'll guarantee you, at the door on your way out, if we blind you leaving here, the chances are pretty slim that you're going to find your way back home. At least not without asking somebody else as you go along. So this is a straightforward prediction, and it suggests a straightforward experiment. That we could take little baby fish before they're on their way out to the sea, we can poke their eyes out, and we can send them on their way and see if they ever come back. Now, you might be able to think of some reasons why in a world full with killer whales and stuff like that, you might still not find your way back, even if the hypothesis was correct. Another prediction we can make is that if the visual cues were altered, they will not return. So we could put a big tent over the stream, poke holes in it that are in different places from where the stars are, and they should have no idea where they're going. We can move the log so it's someplace else, and they can't find their way home either. So this suggests all kinds of fun experiments that you can go out and do. Now, important point here. Science makes, in this example, 2 predictions and more, but it makes multiple predictions. In other words, a really good hypothesis is one that makes multiple predictions and suggests multiple ways of testing it so that you can test it over and over and over again. And we're going to make a long story short. So we do the experiment, we blind the fish, and we find out they find their way back home. Even in a world filled with killer whales, they still find their way back. So what do we conclude? Well, we conclude that if the hypothesis was correct, they would not have found their way back, but since they did find their way back, the hypothesis is rejected. It's falsified, and our next step is we need to go look for a new hypothesis. Now, I want to point out, this is the way all science works. It doesn't work quite as one step after the next as I presented here, but this is the way all of science works. That science works by erecting a hypothesis and examining its predictions. So that means if you think about the logic of this, when science concludes something is true, it's always possible that it's not